So we now have three equations. The last equation I cut off from the last video, sorry about that, is the fact that we are going up through this last battery. We're going negative to positive, and so we get a positive 12 volts here equals 0 at the end. I now need to do the same thing with this green equation as I did with the red equation, and that's to combine like terms. So I'll go ahead and do that next. So negative 3i2 minus 6i3 plus 12 equals 0. I'm going to be using my calculator to actually solve for these three unknown variables. But before I do that, I need to do some little back work with these three final equations. So again, my three final equations are the three that I'm about to star. So I have this one here, I have this one here, and this one down at the bottom here. And the way that I'm going to format these three equations is I'm going to put everything with a variable, one of the I variables, on the left-hand side of the equal sign, and everything without one of those variables on the right-hand side of the equal sign. And I'm just going to list those three equations all next to each other. It's going to help me create the matrix that I need to plug into my calculator. So the first one, negative I1 minus I2 plus I3 equals 0. We don't really have to do anything with that one, so I'm just going to write it again down here. The next equation, that was that red equation that I have up here. I have negative 6i1 plus 3i2. I don't have any I3s. I'm actually just going to leave that blank and then put an equals negative 24. And for my last equation, I don't have an I1. I'm just going to kind of leave a space there. I have a minus 3i2 minus 6i3 equals negative 12. Now the matrix that I create is a matrix of the coefficients. It's a 3x4 matrix. And I ask that when you're doing these problems, you write out the matrix for me so that I know what you plugged in your calculator. And then you don't have to do any work other than showing me what the answers your calculator should be. So basically, I'm just going down these columns. The first equation has a negative 1 in front of I1. The second equation is a negative 6 in front of the I1. And the third equation has a 0 in front of the I1 because there is no I1. For I2s, I have a negative 1, a positive 3, and a negative 3. For the I3s, I have 1, 0, and negative 6. And then the last column is whatever is to the right of the equal sign. So 0, negative 24, and negative 12. So that is the matrix that you need. Okay, so now we're going to plug this into our calculators. And so basically I'm just going to go across and make sure that my calculator matches this. So negative 1, negative 1. This is just positive 1 is the next one. And 0 at the end there. And then I have negative 6. 3, 0, and negative 24. And then 0, negative 3, negative 6, negative 12. Okay? Once you have that all plugged in, you can say second quit. And then you're doing some matrix math. Second matrix. Over to math. Keep going all the way down until you see RREF. It's letter B on the list. Hit enter. And then again, second matrix. I put mine in matrix A. So when A is highlighted, I'll hit enter and then enter again. If you plugged everything in correctly, you should get 1s across the diagonal and 0s everywhere else. And then your last column should have values. The first value is I1, second value is I2, third value is I3. So those are your values. All you need to do is write down those values, and I'm going to talk about what it means that there's a negative sign there. The fact that there's a negative sign for I2 means we chose the wrong direction. When you're giving me your final answer, as you list those three, unfortunately I can't have these two things pulled up at the same time, but as you list those three, I1, I2, and I3, you're going to give me their magnitudes, and you're going to tell me the same direction as what I drew or opposite direction as what I drew. Okay? So I have 3.5, 1, and 2.5 as my values. So 3.5 amps, 1 amp, and 2.5 amps. And I am fine with you just saying same direction, opposite direction, and same direction. Just make sure you have those directions clearly indicated on your diagram so that I can look at your diagram and say, okay, this is the correct direction, this is not the correct direction. So again, you don't have to show me any of that work. You don't have to tell me what you're doing on your calculator. You just have to know what to do. The things that I look for as you're doing a Kirchhoff's law problem, I make sure that you have 3 correct equations. Now, your equations might be different than your friend's equations if you're doing them separately, because you get to choose what direction you went around the loop. You get to choose what your currents are and what direction they're in. So your equations may not match the person sitting next to you's equations, and that's fine. I check them to make sure that they work with what you drew in your picture. So just make sure that I can see what it is in your picture, that your picture is not itty-bitty so I can't see anything. Okay? So I look at the equations. That's where you actually get half the points from, if not more than half the points from, because that's where the physics is. The rest of it is math. Creating this matrix, plugging the matrix into your calculator, getting these final values. One last comment, and then we'll be done with this, is that if for some reason you get a row of zeros on your calculator, it happens every once in a while, just pick a different equation and plug another equation in there. Get rid of one of your equations, try something different. It doesn't happen very often, but it can happen. So if that happens, try something different with one of your loop rule equations.